Okay, I start for the recordings. Okay, as I said, in this training made of 3 modules, we will learn how to develop with MapStore and how to create your plugins, your own plugins, and other technical details useful for daily development in MapStore. Tips and tricks, various things, and also in the its integration in Genode. The first module is basically a checksum of the technologies used by MapStore and a small introduction to that. And we will follow also an integration to understand what is a particular library used in MapStore that requires a little of knowledge, additional knowledge to get to understand. Then in the second model, we will go deep into the MapStore architecture and MapStore developing, and we will learn how to develop a plugin. And in the third module, instead we will see how MapStore is integrated in Genode, and we will see the main modules that made the integration, the Python part, and but mostly the front-end part in order to integrate your plugins also in Genode. We will see also the limitation of the current integration and the future things that will be integrated in the future. Let me admit. I'm checking the participants in order to. I have to stop to share my screen in order to accept more participants. Hi, Edgar. Edgar Malawi is not new to me. I know it.
Hi,
Oh.
Lorenzo.
Hi. Nice to hear you.
Yeah, you're not new to me.
Hi.
You're my mentor at some point in time.
Yes. Nice to hear you again.
Yeah, actually, I was excited to meet you too. Thank you.
Bye. Hi, Haji, too. Okay. As I was saying to your colleagues, I was explaining how the training is made of, and it's made of 3 modules. One for that explains more or less the front-end technologies behind MapStore, one about the architecture, and in the second module we will learn also developing in MapStore, and the third module is dedicated to the Genode integration. Okay, and the main references where you can find almost all the information that I'm telling are in the, of course, the MapStore documentation that is increased a lot in these 2 releases of 2020, and we have now a big documentation about developing developer tech, and so a lot of guidelines and how-tos and information about configuration. It is a big documentation that, of course, requires a lot of time to read, but with this course, I think you will get all the main information to go then in documentation if you need and catch your needings. Okay. As I said, this first module is an introduction to the MapStore technologies. It can be new to someone that didn't use the technologies behind MapStore and never used the React Redux or in general ECMAScript. So I'll do a quick introduction about the technologies used in MapStore. I'm going to start about this model. First of all, questions about this first part? Okay. I'll after this first part, I'll stop for a question time to make you understand, to make you able to give me more detailed questions if you need. Anyway, if you have something that is not clear or please tell me, and please raise your hand, and I can give you the opportunity to talk. Okay. As a developer on front end, I've seen evolving the technologies over time, and this is an interactive chart available on internet of the technologies created and in the front end and in web development in general. As you can see, the complexity is increasing. There are a lot of things new. From 2008, we started with HTML5 that included more things to the previous and basics of HTML, CSS, and so on. Then also CSS3 has been introduced. Also geolocation capabilities has been introduced to allow browsers to share the location, and many other things like different touch events for mobile devices, WebGL to render 3D objects, and so on. And many other technologies, and especially from 2009, sorry, from 2015, the standard of JavaScript evolved a lot. Introducing a lot of new functionalities and a lot of new syntax, and this helps a lot the developers to write the code quickly and write code that is effectively readable by the ones that knows these new features. Anyway, in the last 5 years, JavaScript exploded in many libraries, in many contributions, especially with a lot of libraries behind the JavaScript ecosystem, and so this caused also what front-end developers in general, but also backend, because JavaScript was introduced also on the backend side, in what we call JavaScript fatigue. This means that there is a lot of things to understand, more than the standard JavaScript that we had only 5 years ago, in order to get in the JavaScript development, and this is of course an obstacle for developers. But when you start using these new functionalities with new libraries, you start understanding this system, you may be able in theory to be more effective in development. Moreover, as I said, there are a lot of libraries, so this explosion has the opposite, as the problem that there are many technologies, many small libraries used here and there, and when one developer start working on the front end can be a lot confused because there are many libraries, many things that you don't know, you don't understand, or you cannot get into quickly. And so starting developing with a library in 2020 may be very difficult. So in this first part, I'd like to introduce the technologies behind MapStore and in JavaScript in general, so you can get a little bit more confident with the code of MapStore, and you can understand the code of MapStore, check it, and also get inspiration from that. In order to develop your own plugin. Why this explosion? First of all, as I said, many developers worked on the front-end side, but we had also a lot of new things to think. Only 5 years ago, but when I started, web applications were not so common. Websites were not so powerful as application. But in the last years, JavaScript has been used for develop single-page application that became a lot common. A lot more common. Instead of having programs, you have an application that you can access from your internet browser, and you can work online with them. They became very common, and many products are developed only for the web. Think about Google Documents or or many other tools, and also the mobile gets in. So all the mobile applications or the JavaScript have to adapt to mobile phones, to different screen sizes. Then we had a lot of traffic more, so we needed also some caching, some other functionality that was not required to JavaScript and to web application in general in the past. And for this, you need more libraries, more syntax helpful things, and so on to manage this kind of complexity. For this reason, the many programming paradigms has been developed in order to satisfy these requirements. As I say, to simplify programming, unit testing, or fasten development and maintainability. And these technologies are, first of all, ECMAScript, that is the official name of JavaScript. And it originally was, the original name was ECMAScript, but JavaScript has been introduced as name from Oracle. At the time that it introduced its name, the company Oracle was named Sun. Sun has been bought by Oracle, but anyway, it was a commercial name that because at the age of the when JavaScript has been named as it is, it was Java was so common, so having a name that reminds Java was commercially useful. But the official name, when it is being developed, it was ECMAScript. Now we restarted using ECMAScript or AS to identify all the new developments in and the new versions of JavaScript, but they are the same. The original, developed in 2009, ECMAScript 5 is most used in recent years, and you probably, and I started working with it. For the most younger people, they may be started from 2050. They may have find 2000 ECMAScript 6 or ES6, and then every year new features has been introduced, and now we have ECMAScript 11 that is that has been developed in 2020. We use some of these new functions also from ECMAScript 2020, and I will explain them during this course. Other than ECMAScript, MapStore in general uses technologies that I like React, that is a front-end view library that essentially provides the from the visual components and the part. It provides the system to display some HTML with JavaScript, using JavaScript. It's a library that does it essentially the view part of the application. Then it's a library that is that has been developed by Facebook in just a patch. Another famous library that has been developed in the same time was Angular from Google, the main opponent. And then there is other than from the view part, Redux, it's another important library in the MapStore ecosystem that is a state manager, essentially. And then we...
sorry, Lorenzo.
Yeah.
Are you supposed to be sharing a screen, or because
I stopped sharing my screen? Okay. Okay. I explained a lot of... I explained a lot of things without sharing. Did you see this chart, these parts, and so on? Okay, I forgot to share it. Anyways, I said ECMAScript is this is the list of ECMAScripts, and this is the good to know because I had to explain some code, so it was hard without the screen. Just a second. Probably I had the message in the chat, and yes, it was from you. Yeah, sorry. Okay, and we were here. So as I said, we had ECMAScript. We have React, that is view part. We had Redux, that is the state manager, and we have RxJS, that is another library used often in MapStore. You are not forced to use RxJS in order to use MapStore for simple things, so you can avoid it. It's useful if you need to do complex asynchronous data flows or something like that. We will see it later. And just for show you what I've shown until now without sharing my screen, this is the chart I was saying that is on the internet that shows more or less the technologies introduced. These are the slides I used to explain the needings for this evolution. These are the libraries. These are the main technologies and we are using, we are explaining. And then this is the list of ECMAScript versions from 2009. This is the standard JavaScript, as I said, and from 2050, ECMAScript started to explode with new functionalities that are very useful. And now I'm going to explain them. First of all, questions about this part? Okay. I start you explaining you some of the main parts of the syntax. I will not be I will not go too much in details because you can anyway but I know in detail you can anyway explore whatever you find in this list while you are developing, because having contact directly with things is, I think, is better than a frontal explanation of the syntax. Just a second. Okay. Okay. First of all, as I the first part of this is just a second. Okay, welcome. I'm going to share my screen again. Okay. I introduced for the one that arrived, the ones that arrived. I introduced the first part of the course that is that explains basically the technologies behind MapStore. I will start with the new syntax of JavaScript. The first part, the first point of the new syntax of MapStore that is often used also by React library is it was used in the first version of React, is going to be abandoned during the time for a more functional approach, but you will find because MapStore started to together with React more or less, so with the first versions, and so you will find a lot of class-based components in MapStore. So this syntax is important. JavaScript didn't have a class constructor, a syntax to create classes. Basically because it was based on a prototype system, object system. In ECMAScript 6, this has been introduced. It was initially a syntactic sugar, so it's nothing new. In the first version, you created prototypes with this new syntax, but with this new in the latest version, classes as more details, more things particular of that belongs only to classes. Anyway, for our purposes, they are the same. Basically, class can be created by creating using this syntax, class, and then the name of the class. You can include a constructor that has been invoked on when you create a new object of this class, and here you can assign to this object the some values coming from the invocation of the new syntax creation here, and you can and then you can add some methods to components in order to invoke some methods as well as they are in classes in other languages like C, Java, and so on. Also, you can also extend some base classes, and in this way the constructors will be created in cascade and so on, as well as the other languages, as well as Java, for instance, and so on. In React, we will find often this syntax that will extend React components with base. You can create your own components by extending the base React component. So we will find this new syntax in MapStore. Moreover, one quick version of the function has been introduced that can be written this way. Just a second, I have to admit new attenders, and I am not able to do it without stopping sharing my screen. Okay. Our functions has been introduced in ECMAScript 6, and they are a context syntax for writing functions. Usually, you can write here. I have the console of JavaScript. You can open it by Ctrl-Shift-I, or from here, Tools, Developer Tools, and then you can open the console here on the bottom or here as a tab. And let me detach it from the, yes, here I have the console of JavaScript, so we can try this syntax. Usually functions are created in this way. You can create a function named, for instance, test that does return hello, and then you can invoke test, and this is the return value, that is hello. Here we have a shorter version of the syntax that allow you to you can even create it this way, that is more conscious. The basic syntax is this: the arrow function, the fat arrow. You can use equal and measure symbols, and the parentheses are for the arguments. Return is implicit if you don't use the brackets, and if you have only one line, the return is implicit. So, and these are anonymous functions, and they can be assigned to a variable. For instance, var myFun, for instance, multiply. Here you can assign it to a variable. In JavaScript, it is very common to use functions as variables. This is a basic of functional programming. So, for instance, I have a number here, and I can num2, and I can return num multiplied by num2. And if I call multiply 2, 3, I have 6, as you can expect. Also, if you have only one argument, you can even avoid the first parenthesis. So for instance, if I have a function like this, like var test2 equal a, let's call it add1. Here, this is the syntax. The parentheses for one argument only can be omitted, and the return can be omitted. So you can, for instance, add one, call add one to 2, and you will have 3, for instance. If you have to return an object, here we have a mismatch with parentheses. So if you have to return an object, you will have to use this syntax. So for instance, if you have to create a function called make object, you have argument here as argument of the function. Here you have to use the round parentheses between these brackets, in order to avoid the mismatching between the syntax of the function, explicit function, and the syntax of the object that is uses the same brackets. So, for instance, attribute. For instance, here you can implicit return an object using this syntax. Make object equal, and you can call make object, for instance, to 2, and you will have an object returned that has an attribute with argument 2. Of course, you can define as all these functions also anonymous, and you can, for instance, write the console.log and call them directly. Oh, sorry. Or call, of course, other functions, make object of 2, and so on. And you can write a normal function as you, and you can call it directly here. Sorry. And you will, if you run it, this doesn't return nothing, but only calls these functions internally. And arrow functions has a particular definition of these for those who have seen the old JavaScript. They have seen that the definition of this in JavaScript is very complex because it depends on the execution context. Instead, arrow function, this depends on the definition context. So if I, for instance, create a function inside a class, arrow function inside a class here, if I define an arrow function here, the scope is the definition scope. So here, for instance, if I return this for a function here that is defined in the window, let me return this. It returns the window because it's defined in window context. But if I create a class and here I'm the method inside that, and I create here I create a function. Let me be more, go on more than one line because it is not clear. Here I have a method here, I create a arrow function here. And execute it. Anyway, I can execute it from, and then I create a new test class. Create a new test class, and I call the method test method. I add these created in this context, that is the test class. Instead, if I returned simply these from this class instead, here I'm going to redefine the class, and I return simply this in a normal function. In this case, test method. If I add a normal function, sorry, here, instead of having, let me go back in the history, okay. If I add instead a normal function here, this function depends on the execution context. In this context, we have the same, but in some, if I return instead this function and execute it, I will have this different this. If I return this function and execute it, I will have, instead of having this the class in the scope, I may have some different behavior that is not wanted. I know this is a particular thing. This is strange for not JavaScript users, but for JavaScript users, it's very common to have problems with this. With arrow function, you will not have any problems with this object, because it's well defined and on definition time. Let's go more in. Okay, so we have seen classes, arrow functions. There are also some other way of defining variables. Instead of var, you can define const variables equal my const. That can, if I try to assign the variable a const variable, I am not allowed on runtime. This is not. This is if I define instead var a my var var a, and I try to assign another value again. With const, I'm not allowed. Moreover, let var is an old syntax term of JavaScript that has a function scope. So a var definition is valid for all the function. Instead, if you need a block scoped variables, that is almost 99% of the times you need a variable, you need only in the block. So you can use the new let syntax to define these variables. Let me close this console in order to reset the variables I created to avoid new name is matching with variable defined before. And so, as I say, classes, arrow functions, quick way to write functions. Const and let, you will find them very well, very often. Then there are some practical things to create objects, to access to objects sub elements. So if I have an object, a nested object like this, that has attribute 1, and nested attribute 2, and nested attribute 3. Typically, when I try to access to an object, if one of the part is null, to .at1, .at2, I can do it. But if one of these is null, at2 for at3, I have typically an error like this. This syntax, this was typically avoided using this end that for JavaScript has a particular behavior that helps to skip these errors, but has some unwanted behaviors in case we have, for instance, values like 0 or empty strings or false values is not so. You may find some unpredictable things, or you can quickly create bugs. In this case, instead with this new syntax called optional chaining, you can quickly access to one of the attributes, and if, for instance, the first one doesn't exist, I don't have any error, and it returns undefined. Together with this, we had nullish coelish. That is a strange word to assign a default value if this is nullish. So typically, a nullish object is in JavaScript is an object that is null or undefined. That are two ways to define non-existing things. Undefined is typically an unexplicitly null object, while null is explicitly wanted to be null, because you have to, by default, things that doesn't exist are undefined. Instead, if you assign a particular value null to a variable, you want to assign it, and so you have an explicit assignment, and so you are sure that you are using null. You want it to be a null object. So this is a way to assign default value if they are null or undefined, nothing more. So as I said, classes are functions, const let, optional chaining that allows to access nested objects, and assign default values with nullish coelish. That is these two question marks syntax. These two, this and this has been introduced in ECMAScript 11, so they are new of this year. Questions until now? Let me see the chat. Okay. I can go further. Okay. Moreover, there is a very useful operator that we'll find very often in MapStore, and it is the spread operator. The spread operator can be used for objects or for the definition is quite a little cryptic, because a spread operator allows an iterable to expand the places where are 0 or more arguments that are expected. It's strange, but I'll explain it basically, spread operator is this three-point operator, and is very similar to the to the rest operator that has the same syntax. Now you will see them used dually, and let's see first the spread operator. Spread operator allows to spread an object inside another object, and it can be used for arrays or for objects to spread all the elements contained in it into another object. For instance, here we have an array of 3. We define an array. We can start using let just to make you confident with the new syntax. Let array. Let's define an array of 3 and 4, and then let's create a new array that has 1, 2, and then you can spread the first array inside this. This will create a new array with the concatenation of this array and this other array. I can even create add points here, add elements before and after, and this is very helpful to concatenate arrays or concatenate the same syntax can be used for object. For instance, if I have an object like this, let's see, I used some wrong thing. Unfortunately, the slides doesn't have the correct double apex. I already defined the object. I can delete it. I cannot. Okay, let's call it object 2. Object 2, obj2 as these attributes, and if I create a const new object, I can spread all these 2 arguments inside the other new object. J, C, and so on, D, and the new object as I used. Okay, I defined before this object, so I used obj instead of obj2. So here I can show you as important as you can see here, I cannot assign the new object anything else because it is const. So I denied. So let me close this console and open a new one in order to get the okay. I have to reverse. Okay. I cannot work with this. Let's as we did before. Let's call it object 2. Oh, okay. I have to close. Sorry, I opened it in the same tab. So this is the reason why I already defined that variables there. Okay. For instance, here I have a non-obj. Let's use A for the exercise in order to, for instance, okay, I'm stupid because I opened it again in the same context. Let me close it and open a new console. Okay. Oh, now I can. As I say, the const new object, I can assign, I can do this, and I will see new object that is made of A, B, and C, D. If I create new, this is very useful because you can override existing my old existing attributes, spreading them inside them. So here, in this case, obj has the attribute A defined. So I will override this one with my new one. So here, new obj2. I will have the A, and this has been overridden. They are in order, and so it's very useful to create objects, to merge objects, and it's very used inside MapStore. And we are almost there. I don't want to bore you too much with the syntax things, but they are important because they are often used in MapStore. So yes, let me include the other attenders. Okay, so I was saying there is the spread operator that can be used for arrays in order to concatenate arrays and so and spread them inside the other arrays and so on, and the same can be done for objects. Please, I have to mute some of you because I'm hearing some noise. Okay. As well as you can spread object, you can extract object with this destructuring syntax, and you can from this new object you can get the variable A or the variable 2 by simply creating a variable with the same name. For instance, let's see, let A be equal from new object 2. In this way, I create a variable A and get the attribute A from this new object 2, new object 2. So for instance, A in this case has the A and B as B. I can even change the name using my var using this syntax. And in this case, I get the attribute A from the object and assign it to a variable, my var1. This is the same of doing let my var1 equal new obj2 dot A. This is a shortener version for this. Of course, if this as well as this and the same for B, and this is the same of creating let A equal new obj2 dot A, and the same for B, let B new obj2. As you can see, this syntax is very long, this syntax is very short and is understandable, and on a quick look you can identify what you are doing. As I said, a similar as I said, a similar syntax used for the spread operator has a similar the same syntax of another dual operator, that is the rest operator, that does the structuring with that does the opposite of the concatenation. It extracts the remaining values. So the difference is that the spread operator is used on the right side, and the rest operator is used on the left side of the expression, on the assignment, or in a function. This spread operator helps to get the rest of the values. For instance, here I can create, I can do my var A, my var B, and then rest. Then I have rest object with the new object 2 as a C and D, and other than A and B, and the rest is G and D, and is assigned to this variable. So rest variable contains the rest of the operator assigned by that. The same things can be done using arrays. For instance, if I have an array 1, 2, 3, 4, I can do var n1. The structuring can be used also in array with the same syntax. This means get the first and the second element of the array, and then I can use this spread syntax, but is the rest operator in this case. Rest of array to extract values from the array. And in this case, n1 as the first element, and 2 as the second element, and rest of the array, variable contains the remaining value. Is an array made of the rest of the elements. Rest operator can be used also for argument of functions or arrow functions. So for instance, if we have an arrow function defined like this, a order args, return order args, here, if we call this function, we self-assign this function get order args. If we call this function with a series of arguments, the first argument is assigned to A, and the other args 2, 3, 4, 5, 6 are passed in this variable inside the function. Okay, now I think I bored too much, so maybe if you want to do some questions or ask something more, you can. So you can relax a little bit. If you are okay, I can proceed. Otherwise, I can stop a little. Okay, if you don't tell me nothing, I can proceed. Okay. Nothing, not too much more, because it's becoming boring. Of course, in a function you can use default values using this syntax, as well as other languages. For instance, you can create var function with default arg, I didn't assign it. In this case, I assigned one to the our first argument, and if I call this function without arguments, A will get the 1 value by default. We have almost finished with the syntax. The only thing that are remaining are array new functions that allow you to create new. If I have an array like this, I can apply new methods introduced in this language as map, for instance, that allow to pass a function as argument. And this map function returns a new array, processing every argument and every element, and with this function, and returning one value for each element processed. So, for instance, if I apply this function to the map, I map this function to this array, I have a new array with all the elements multiplied by 2. I can, for instance, add the 2 to the elements, and for instance, here you have 1 plus 2, or 2 plus 2, and 3 plus 2. Another method added to the arrays in ECMAScript 6 is filter, that allow to get a function to exclude some elements for the array, and returns, even this returns a new array. All these functions doesn't modify the array, so they are very useful for immutability in order to avoid old variables to be mutated, and so have unpredictable state. For instance, here I can filter all the elements that are greater than 2 or greater than that 1, and it returns a new array with the elements that satisfy this function. There is another operator, more complex operator. I'll not go deep down into this because it's not so much, but anyway, this reduce allows to process an array and returns whatever you want. You can, for instance, use it to create some summaries or some other arrays yet, but with this reduces a more generic map version, because it allows to get use an accumulator in our variable in order to accumulate results. For instance, here I can create this, use this syntax to sum all values and accumulate them. So I can sum the first element with the second, and then store in the accumulator this sum, and then apply this sum to the next value, and so on. And this is very helpful if you have to process some values and get a single result or a single checksum or something like that. And this function can be combined, so you can use map because they returns array. They can be chained, and so you can do a map that adds 1, then a filter, and then reduce, and so on. Reduce, of course, return is not mandatory to return an object. It can return whatever it wants. It returns the final value of the accumulator, and so if you can concatenate it only if it returns an array too. Otherwise, you cannot add the map to an object that doesn't add map method. For instance, in this case, I add 1 to all the elements, and then I filter all the elements measured than 1. But if I change something, you can see there is a difference. Okay. I finished with the new syntax. That is the most boring part. let's summarize. So we have classes, arrow functions, new variable declarations, syntax, quick versions of syntax to get access to nested methods or assign default values, to spread objects inside and merge them, and or to extract variables from objects or from arrays. We have ways to get the rest of the extraction, so we can extract many things, many strategies, and we can use many strategies to extract pieces of variables and other from object, or to spread inside them, or get arguments and so on. We have many syntax highlights, and then we have a way to quickly process the arrays in a functional way, more or less. And this is more or less the syntax that we will often find in MapStore. If you take a look at MapStore code and take a look at a plugin, for instance, sorry, if you take a look at plugin, plugins are here. We will see in the next lesson all the structure of MapStore in general. But if you take a look to plugins, you will find classes. This is an old component. You may find ternary operator, but also spread operator is used often to assign variables. And let me find it, some of them, for instance. Now I cannot find the spread operator, but anyway, you can find some. Yes, this is a map on the array, for instance. The second argument of the optional argument of the array is the index of the array. Anyway, this is a map. As you can see, a filter here, a reduce here. So you often find this kind of things when processing arrays or when processing objects. And this is the syntax that we will see later. Anyway, here you can see the spread operator and so on. So it's often used, so it's useful to have an idea of what they are. In order, the last thing new to the ECMAScript, other than the syntax things that has been introduced in ECMAScript 6 is the promise. Then after this explanation, we will go deep down into React, and we will see React, Redux, and the libraries included in MapStore. So we will go more near to MapStore. First of all, let's introduce you what are the promise. Basically, when we usually do AJAX calls or asynchronous calls in general in JavaScript in the past, we had typically to call a function and then pass a callback function. Here is passed in line, and this had passing the callback can be useful, but can be manageable some ways, but it has the problem that if you have to do more asynchronous things inside after you get the data, for instance, ask for the data or wait a moment, delay a little bit the response, you may have a chain of asynchronous things. That means a chain of callback calls, and code written in this way becomes quickly hard to maintain, and this was called the callback pyramid of Doom. So promise is a pattern for doing asynchronous things. It's not only the only pattern used at MapStore for do asynchronous things, but it's a pattern that tries to represent objects to create an object or create a representation of an incomplete operation. This way, representing with a promise an incomplete operation, we have this object that has been created and represent this operation, and this object has some methods to react to the events of a completion. When the event is complete, you can pass the callback here in the method instead of passing it directly to the function. And you may say, what's the difference? The difference is that if you here inside the callback we return the same representation, the same promise here, you can chain them because you can, if return another promise, you can concatenate to this function, this then calls another callback with the same in this way, and you can concatenate many asynchronous calls. These allow you to transform this callback pyramid of Doom into a linear version, a linear pipeline of callbacks. So if you, for instance, you have to do a request to the server to check the presence of the server, and or to check some URLs to do the request to, and then do the effective request to the server. If you don't use promise, you have to do a chain of callbacks, and then if you have some errors to handle or it's difficult to restart the flow and handle the errors, and it's even not so easy to understand the flow because you are chaining callbacks. You are calling function inside other function inside other function, and it's difficult to follow the execution. Instead, with the syntax is more cleaner. So for instance, here you can call do a Ajax request and do another Ajax request, and then if some error occurs, you can apply this method in order to handle any error coming from this pipeline. And this is very useful for asynchronous data flows that becomes complex. ECMAScript provides a syntax to create promise. This is the syntax. I don't want too deep into this, but anyway, you can create a new promise using new promise as writing new promise and then passing a function that has two callbacks here. One to execute if when you want to return. Here you can do some asynchronous things or whatever you want, and one for reject if you have some errors, for instance. And if you call reject somewhere, you will follow in the catch mode. So you create a promise, and then you can call as much functions as you want, and you can chain them together in order to do asynchronous data flows. This is not so clear at the beginning, but usually most of the time you will see only this one, only thing like this in MapStore, Axios dot. That is a library to do Ajax calls using promise. This is a library used in MapStore, and you will see often Axios.then something, Axios.get, for instance, that do those get requests to the URL, and you can apply then, and here you can parse the result of the request. Simply, this is the basic syntax that MapStore uses to do asynchronous calls. It uses Axios to do asynchronous calls and then process the results. If you have to do another request inside that, you have only to return again Axios.get the new URL, and then here you will have the result of this request. Here, as you can see, is more linear than having nested callbacks. Okay, with syntax we have finished. If you want a small break or if you want to put some question, this is the time.
Hello.
Hi.
Hi, Lorenzo.
Hi.
Thank you very much for this great presentation.
Mm-hmm.
I have one question. I've seen you are using promise.
Yes.
Promise pattern in handling asynchronous data or asynchronous actions.
Yes.
So I wanted to ask about async await pattern. Is that also allowed in MapStore too, or there are some? I've not heard you mentioning that.
Yes. Good question. Let me mute you because I have. Okay, thank you. Actually, async await is not used in MapStore. We never used. I think it's allowed in the terms that if you have a browser compatible, it will work, of course. We didn't use it because we started when MapStore started when async and await was not existing, and I'm not so confident with that syntax. I know that exists. I use it a couple of times. It works. Is allowed in general if you in your own project. Most probably in using it in the main product maybe refused because it's not part of the. We have a lot of technologies yet inside, and so we have to exclude some of them. We are going to define the future to clean up all the technologies that are going to be replaced with new ones. I give you my opinion on async await. Async await sometimes hides the complexity, so I don't like it personally. But in many simple use cases is very useful, and so you can use it in your own project when we will talk about MapStore projects. You will know better what is a project that you can handle on your own. But in MapStore is not. I never used. We never used async await. Maybe some libraries inside them internally use it, but MapStore is not part of MapStore in general. I hope I replied your question.
Yeah, yes, absolutely.
Okay, fine, thanks. Other questions? Do you want a small break, 5 minutes? Because I explained a lot of things, so maybe you can be not confused. Okay, let's do a small break. Let's get back to the at 35. It's okay for you?
Yeah, it's okay.
Okay, so I have 4 minutes of pause.
4 minutes, yeah,
Okay.
I think is enough. Yeah.
Thank you. Let me pause the recording. Okay, just to have a mental break, I explain the features. I'd like to show you a little bit MapStore in order to have, instead of seeing a code all the time, you can see some graphical user interface and some web pages and maps. So you can have a little fun seeing functionalities and so on. Before to restart, just a second, let me share again. So before to restart taking a look at the code, let's see a little bit the functionality also of MapStore that you may have missed. First of all, for the people that is relatively new to MapStore or don't know it, MapStore is typically a couple of things at the same time. Is a framework to develop a web application and it's a product by itself. During this course, we will see MapStore as a framework to develop your own applications, and MapStore as a product. We will see as from the developer point of view. So we will see the structure of the product of MapStore and the parts that is made too. But I'd like to introduce a little bit more in the product and the new features in order also to have a break from code and take a look to the functionalities. Mainly the MapStore product by itself is a Java application that can be installed on a Tomcat or whatever server container you want. And it basically is an application to share maps, to share contents that have typically special things inside that. So in the new version, in this new version of MapStore, we have introduced some other contents. Typically, the main content type of MapStore is a map. Here you can have a map that is basically a set of layers with some other things inside that. And here you can add layers from catalogs. You can handle many. The catalog is basically a browser for some well-known protocols to browse some layers and special data to add to a map. Here you can add some layers from some servers. Here and that, for instance, you can add this. These are the UNESCO items in Italy, or for instance, here you can add the layers from Tasmania. Now these particular layers in this server has problems. Anyway, for instance, here you can add the raster data. Okay, I'm using a server that is having problem now. Anyway, we can, for instance, inspect data. We have some way to filter this data, and let me use a more stable server. Let me see. Okay. This is the same. Okay. Just another attempt, and then I'll okay, this works. Okay, here I have I can browse data and filter them. There are some features here and there that has been introduced to create the filtered versions of the layers. For instance, here I can filter by attribute. For instance, the state name states that as a name in the name. Sorry, I have to do this. State name that has a name in the name. We can also do some cross-layer filter. So use another layer that I can use is method. Don't take into account this tool for the moment. Here there is this is a list of method landings during the history, and I can even filter data by intersecting with other layers. For instance, here I can use the states to get the method landings that happened in Alabama, for instance. And as you can see, the layer is filtered by this. Or for instance, for Colorado, this is I can filter layers with other filters. I have this is also a temporal layer, so I can reset the filter, and here I have if I have some temporal data, I can browse and manage the time. I don't know if you have seen these features anyway. I can go here by here and element by element here. This is a nearly map because of method landings. So I can go here by here to browse data. Anyway, this is a timeline to browse time data that has time dimension, for instance. There are many features like that. I can even create some widgets that do some statistics on the layers. For instance, I can do a chart of the states grouped by region, by subregion, summing, doing a sum on the land of the land kilometers, so on the I can, for instance, create a chart that shows for each state region. So this is the mountain region, that is the central one. This is the Pacific region, that is these three states, and I summed, for instance, the data on that layer. And moreover, I can add more widgets and so on, and share these maps with the my colleagues, saving them. For instance, if I log in, I can save the map and share with some user groups and so on. So I can, for instance, share with my collaborators and allow them to edit this map only to view and so on. Maps are one of the contents in MapStore. The other contents are dashboards that are mainly some. They are similar to the widgets. Here there is these tools are synchronized. And dashboards can be created and add the widgets with some, for instance, text. but also charts, tables, and so on. You can see dashboards here in the demo, for instance. Let me include the other ones that are joined. Hi. So as I said, you can share with your colleagues, with your groups, with the groups that belongs to MapStore, that of users in MapStore. You can share maps, and the maps can be can contain data from very well-known layers, and dashboards are different. Are a set of widgets, a set of small windows that that can contain charts and maps and legends and so on, and they are all synchronized. So as well as you zoom, the chart are updated to show, for instance, only the data in this viewport, or I can even filter here by for instance writing a string here, or by date, or so on, and so on. As you can see, as well as I zoom, I have less values here in the chart, and so on. And you can create new charts and connect, for instance, a counter of this point of let me see, for instance, if I inspect this layer, this map, I have this layer with this name. Is a name in Italian. I'm sorry for that, but this is a layer of works, of pending works in this city, and you can, for instance, add the counter that counts these offers. Okay, I cannot do it in this demo, but anyway, I can, for instance, edit this in order to okay, or to change this chart, for instance, in order to change the chart from chart type or something like that, and so on. And other than dashboards that are very useful to do statistics, to show some data, and there are stories that has been introduced in the latest version of MapStore that allow you to, let me show a simple story, to tell stories with the maps and so on about with a scrolling interface. So you can see this is a typical story that scrolls. They are maps that are working, and these are, for instance, a web page that explains the list of the higher astronomical observatories around the world, and it shows, for instance, the history, and shows a map, and this is interactive, and I can click on the map and see pop-ups, for instance, and go down, and as you can see, when I scroll, the maps change, and I can see information about that, and so on. And I can see even videos, and so, I can include in this. This is a small tutorial. I can skip it. I can edit the background, adding videos or maps, or background, for instance, here. For instance, I can add instead this map and So I can edit whatever I want in order to, or edit the contents here with a easy. I can change the syntax, of course, and the contents, and add more contents here very quickly. For instance, here I can add the new section here and add the background with this image, for instance, and some text here. And here I can go in preview mode and see what is the final result. These are very beautiful in order to do presentations and so on. This is one of the new things. And another new thing is the context. That is a way to define a small subset of. Typically, when you have the map, you have a fixed set of tools here. You cannot choose the tools you have. And if you are administrator and you have the latest version of MapStore, you can even create contexts. So they can contain a subset of tools. As you see here, for instance, you don't have the 3D or some other tools, and you have a preset of maps if you want. And you can create maps based on this context to create a small application. For instance, you can create your own plugin and show it only in this context. So you have a subset of tools of your own, and that is more or less a small application focused to your contents. And it's very useful to do multi-tenant applications with many different tools. As you can see here, you can edit the context by editing the base map and add the plugins you want. MapStore is based on plugins, so every tool in the map, every tool in the home page, and so on are plugin. This search tool is a plugin. This menu is a plugin. These entries are parts of the plugins, and so on. The footer is a plugin, and so on. So they can be plugged and unplugged from the application, and the context tool makes this very useful in this case. And for GeoNode users, MapStore is also a library that provides mainly the viewer, the map viewer, but in the future we have plans to introduce also these new contents inside GeoNode. We are going to define some in these days. Yes. Next week we will start to define the future of the integration of MapStore in GeoNode in order to introduce this other kind of contents, if possible, of course. So I hope you had a little break from code, so we can go back to the to the JavaScript and restart having edge. Some questions about what I said? Okay, fine. So let's restart. Let's recap first, also for the people that joined in this way. The first part of the presentation, I explained the new syntax of used by MapStore, the new syntax of JavaScript, and the main parts was classes, are functions, and some syntax useful things that are often used, like spread operators and array operators and other typical things of the new JavaScript versions. Then I introduced also the promise that is a way to do asynchronous data calls in a better way. Okay, let's start now with the libraries used in MapStore. The main library used is React. React is JavaScript for busy. As I said at the beginning, is a library made for building user interfaces, so it's the main view part of the application. Is a library developed by Facebook in order to create some sort of a component-based way of defining the user interface. So you can, in React, you can define components that are some sort of complex. If you have a, if you remember HTML, you have base tags that has base functionalities, and the component is an extension. It's somehow an extension of the tag concept, because here you use the same syntax that is defined at JSX. Is an extension of JavaScript that React provides in order to write some sort of mixed JavaScript and HTML-like syntax to create these components. And as I said, components are more or less the same, use the same syntax of the HTML tags, but instead of being simple tags that can be complex, more complex, contain other basic, they are containers for basic HTML tags. And so you can create, for instance, a component that is called welcome, for instance, that is defined by this template, for instance. And this template uses basic HTML tags like h1 with this h1 tag. This is a title, and this syntax allows you to inject properties passed as attributes, as well as you define attributes in HTML. So this is a sort of template to create HTML. You create this template as a function. In the first version of React, we they provided the syntax to use the classes, but this is almost the same thing. Classes add a render function that is more but most of the component add only the render function. Let me show one of the React class component. Now let's switch to English. Yeah. A class that, as I said before, extended dot component. They had render method, and moreover they had more methods optional methods to handle the life cycle of the object. In the new version of React, they used to migrate and suggest to migrate to a functional version of these components. So in this case, a component is only a function that basically has the same purpose of the render function of the other classes. And basically they are, as I said, the template. This is almost the same component that we had in the initial example. And when you want to render, sorry, I missed it. Okay. When you want to render a component, depending on the React can be used both in native applications or a web application or whatever you have. You have UI. In our case, we are developing on web, so we have an additional tool that and an additional library that is React DOM, and this React DOM has a method render that allows to render a component to a specific element in the document. If you see the screen going and getting back, is because I am admitting new people to the call as well as I explained. As I said, React in the web application we have React DOM that has a method render that allows you to render a component that is basically a template that is written in the same way you usually write an HTML tag, and the arguments can be used as the attributes of the tag can be used as props. This is the main arguments of a component, and they can be used inside the template using this syntax basically to be added inside them. And React DOM is the specific render tool for web applications, and allow you to render a component and so apply this template and render all the HTML written in this template. Here you can add more components inside that, so it will become quickly a nested set of components that renders together all the HTML you need. And this renders to a particular tag in the document. So here you have a tag, a div with the ID root, and this welcome will be rendered to the root element of the DOM. Here in React you can define a lot of components that uses other components together, as I said, and you can create a tree of components. For instance, an header, a component for header, a component for footer, a component for map, a component for token. If we look at MapStore, all these are components. So this is a button component, a toolbar button component that has a particular properties that you can pass, like the tooltip here or the icon and so on. And you can define components that have an interface defined by props. So you can pass, for instance, the here in properties for the button, you can pass the icon, the tooltip, and so on, and render them in HTML. And everything here is a component. This input is a component. This menu, this window, everything is a component that contains other components that at the lower level contains HTML basic tags. When I say rendering, I use rendering for two different things in React. Rendering is the effective writing on the DOM. So writing effectively, modifying the DOM, so doing document.append child, the old functions or something like that. This is an effective rendering on the DOM, on the document object model of the page. But rendering in React has a particular meaning because React has what is called a virtual DOM, separated from the browser effective DOM. The object model the document object model is hard. Sorry, let me restart. This rendering operation may be rendering all the components all the time. Maybe they very problematic in terms of performance, because you doing this render every time may need to, if you have a complex object inside that complex nested set of components, it may need to access to the DOM very often, and the browser DOM is slow. To prevent this problem, React internally contains a virtual representation of the document object model, and when you do this render, in fact, React compares the old version of its virtual document object model. Let me make it a little bigger. This old version with the new version, and check what changed. There's a difference, between the old state of the virtual DOM and the new state of the virtual DOM, and apply to the browser DOM only the effective change. For instance, here, if I do another render, change the name John with Paul. If I don't have React behind, if I don't have the virtual DOM behind React, this means that I have to render the old welcome, and so I have to rewrite this component. This is not a problem, but if I have a complex nested set of components inside other components and MapStore is it. MapStore is a set of components rendered only one time. This becomes very complex. For this reason, React, in order to allow to do this render as much faster as possible, compares the old version of the DOM with the new one. For instance, in this case, only this part changed, and so it doesn't recreate the H1 element, but only doing the comparison on to the effective DOM. It will only replace this string and not the full set. This is not visible in a simple element, but if you can imagine a big structure of elements and components contained, a big page full of tags and so on, re-rendering and rewriting everything all the time, it's hard to maintain. But doing this, you can simply do another render here, and don't care about the performance, because React will do it on your in place of you. Of course, this is only one of the optimization that you can do, and also comparing the virtual DOM may be a problem in terms of performance if they are big, and there are other solutions that you can React allow to apply if you have complex objects or in order to cache and in order to avoid to do the comparison all the times. And so this makes this is the very strong part of React, because you can write code without taking care about performance, and if you need some performance optimization here and there, you can apply quickly and this at that specific scope, and re-render everything all the time without taking care of performance, because React will do all the comparison, reapply everything for you. So you can only render your component and don't care about the performance, or when you care about performance, you can quickly add a piece of code dedicated to that inside the component that take care of that particular problem in performance. So you can render this. This rendering technique, render on the time technique, is part of an architecture idea that born with React, that is Flux. The architecture is not mentioned too much. This architecture is not mentioned too much because is often taken to this paradigm is has been absorbed by Redux in almost all, but the main concept remains the same. Angular, this Flux architecture is called one direction data flow, and this one direction data flow means that data flows only in one direction continuously, and is the opposite of the two-way data bindings that is typical of Angular applications. I don't know if you heard about them, but anyway, Angular typically has a two-way data binding that binds the components directly to the data and vice versa. This was a problem in Angular because the performance go really slow. And so for this reason, you have Angular 2, because they had to do a lot of changes in order to make two-way data bindings work, and this is why React in the meanwhile with this paradigm had so much space and so much and became so used because of this alternative paradigm called one-way data flow that is simpler. So you have the state somewhere. For instance, you can imagine your properties, these properties that you pass to the main container component, stored somewhere, and when you change them, you do a render, so apply to the view, and the view if you re-render the render, the view is updated. Then when an action, or for instance a user click happens from the view, there is a dispatcher that updates these properties stored somewhere, and the properties stored somewhere are updated, are passed again to the render again, and the view is updated with a new render. And this paradigm is some actions can come from other parts, for instance, from Ajax requests and responses and so on. So more events from the view, or events coming from Ajax response and so on, the only thing that they do is to update the state, and so the properties, and so re-render, as well as the state is updated. The whole application is re-rendered, and with the optimization you see here, and only the effective changes are applied to the view. This is the main idea. The main idea is implemented by a library called Redux. As I say, the implementation of this Flux architecture is Redux, and is a way to define these store and these action tools. So view is React basically, and all these dispatcher, store, and action are implemented by Redux. Basically, Redux is a simple library that provides for a state as a state container, functional state container Functional means that is programmed in its functional programming paradigm. So all the state is created by functions basically, and new actions are when you have an action coming from the view or coming from wherever, you will have a dispatcher that will call all the reducers that are function that mutates the state based on actions, and the state is applied to the view and updated. So if you take a look at Redux, other than how to install it and so on, the Redux is simply a state container that where every slice of every piece of the state is implemented as a function. A function that gets state as first argument and an action as second. Every time an action is performed here, so in this cycle, as an action is performed here, the function is applied, and if typically a reducer is a switch in this case, if the action is one of the one you decided that mutates the state, this function simply returns the new state mutated. It is intercepted by this. An action is typically an object that contains a type here, and if the action is one of the ones you decided writing this tool that mutates the state, it mutates it, and otherwise it returns the old state. Then, so as you can see, this is what we call a reducer. That is the core element together with the action of Redux, and this represents the state. And so, if you create a store with this reducer, you can dispatch action to the store and change the state. If you dispatch this action incremented to this state, the state increments, and so on. If you create an action that is not incremented, decrement, the state will remain the same, because every time this returns the new state, and in case you don't mutate it, it returns the old state. So every time you dispatch, this function is called with the old state as a first argument and the action as the second. And this cycle, or every time an action is dispatched, all the reducers, if you have more than one, all the reducers, and this is the case of MapStore, all the reducers are called every time you call an action, and the state is updated. And when the state is updated, in Redux, there is a glue library called React Redux that connects Redux state with the view, and every time the state updates, it re-renders the components. So, just to summarize this first part, let me check the things here. Okay. Just to summarize, as I said, we have React that gets the view part, a Redux that with this function called reducer, this is every R here is a reducer that, and the store contains all the state from all the reducers, and every time the state is updated, the application, this library React Redux has this connect function that allow you to, that can be applied to a React component, and basically maps state, the whole state of the application with the properties passed to the component. So these properties can be mapped by this function. Okay, let me be more clear about this point. As I said, the general concept is that every time the state is updated, the view is updated. And every time the view or somewhere else an action is triggered, the state, the dispatcher is called, and the reducer are all called in order to, and some part of the state may change. And if some of the state may change, this state will be propagated to the view as properties of the components, and if these properties change, the view will change accordingly. This glue between React and Redux is applied by this library called React Redux, that has one function mainly that you have to care about, because all the glue code is made by MapStore in MapStore. So the only thing that you have to care about is this connect function. The connect function maps the global state to properties. So here there is a function that gets the global state as argument and returns properties to apply to pass the component. Here this is a function, and in the simplest way you have to simply apply this. Here you have a component, like for instance welcome here, this component welcome, and here you can apply connect and create a new component, const connected welcome. Well, connect a function and I apply to welcome. I remove for the moment render, because rendering in this case is applied in another way. Connect, here we have a function that gets the global state and returns the properties you have to pass. For instance, I have the property name. I have to name state dot reducer name, for example, one dot name, and this maps the global state of the application to the properties. This component will receive the property name, and every time this with this connect function and the system that we will see later, every time the state is updated from the action, the component will be automatically rendered with the new property value, and this is automatic. Let me admit another. Okay. Okay. This is a simple application with all the pieces together and arrows that tells how they are connected. Basically here, let me zoom a little bit. You can see a simple action creator. Okay, typically the actions are object with a type, as I said, but to create an interface, to create actions, typical actions, we usually create actions creators that are functions that returns this object simply, and with some parameters. So you can create, for for instance, a setText function that creates an action. setText function that is an action creator. Sometimes we use in Redux world actions are named as action creators and so on. Usually is clear the meaning of the one when you say action and you mean action creator and or not. But anyway, the action, formally the action is the object and the action creator is the function that returns an action. Simply. Here we have a couple of functions that creates some actions. So setText and inc. The first has one argument, the text, and an increment. So we have two actions that can mutate the state. Then we have a reducer, only one reducer, that have an initial state. Here you see the default argument assignment with the initial state, so that is initial test and the initial count. And the reducer by itself intercepted the setText, the actions with the setText type to update its own reducer state and keeps the same count. The count is kept as the same. These reducers intercept also the increment value. So it intercepts also the increment actions. So every time the increment action is triggered, the counter is incremented by 1. For instance, you can imagine this as a counter with a title. This is an application that has simply a counter and a title for that. These two are simply functions, so they are not connected together. So they don't work on their own. And the Redux library provides this create store. All this store and all these parts are, except the connect function, are made directly by MapStore. So you have only to know that they exist, but you will not have to use it when you develop in MapStore, except you're working on the core part. So the store is created by Redux library, and here we have a simple component that is a title with onClick method that can be applied, and here also the second part of the connect method is included that allow to dispatch actions automatically from the dispatch action from the components. So here you can pass as properties simple variables or function to call, and in this case if you pass them here in this object that is passed the second argument, they are automatically dispatched as actions in the store. So this is a quick way to dispatch actions interface. So here we have a simple component that uses that as a actions properties inc action.inc property that is a function that is called onClick, and then it renders the text passed as properties as property as it renders the count. So it has 3 properties: actions that has another nested object inc that is a function called onSync, and then and other 2 properties, text and count, that are rendered here. Is it clear what is what it is? It is an H1 element. Let me get just a second. Let me get sorry. Just a second. I'm trying to run a sandbox in order to show you what this component does. This is a simple sandbox that you can usually find on the internet. There are thousands of them. Here we have an h1 tag. With the on-click method that has is not props. In this case, this is a functional component, so I can try to use a functional weight to it anyway. Export class. There are many ways to define React classes during the history of React. This is one of them. Using also classes is a way. This is the way where you can use if you don't have the classes in JavaScript. But anyway, at the actual moment, you can easily use a class, and all the browsers understand it. We have the render method here, and you can return an h1. Okay, I don't care about it, and on click. And here I have to write it because it's an image. So sorry, I forgot to. If, for instance, I have if here I add some text, and here I have one, I should see simply text to column 1 and so on, and that's it. Okay, so apart from the component that is all, for some of you maybe new, and so I explained a little bit more. The connect functions to returns the state because they have the same name, so this in this case you can only you can return the full state as property, and you can here the second argument is the map dispatch props. Here you can, in the second function, you return the actions to dispatch, and in this case you call this function to do this bind action creator. That there is a function internal to Redux. Anyway, in MapStore this is more simpler than this. And then you have this provider that is in the main code, and in the render you have this part, and these do the glue code of all the connection between the state and React. I'm going fast on this, and I don't explain all the parts because, as I said, in MapStore everything is made by Connect, and we will learn it a little bit more later. So when we will develop a plugin, we will see this part in detail, only this part, because everything else we will write essentially in MapStore connect, actions and reducers and more things around that. But this store part and this provider and render part is are done by the framework. So MapStore will write components, of course, for the graphical part. You will connect your components to the state and write actions and reducer to handle the state. But basically, everything is done by the framework. So this is a way, the complex way to represent this cycle. The properties updated the render and so on, and then the action or action creator, as I explained, are dispatched to the user. They update the store, and then there are functions called selector that can be used to extract parts of the state inside the this is a selector, gets the state and gets parts of the state that can be used, for instance, for props. But in the Redux world, connected components are almost all called sometimes containers. So this is the connected component that with this MapStore to props function maps it. No, it is not MapStore, but it maps the store to the properties of the components. It updates, and this is a cycle basically. This is the same cycle you can see here: action, dispatcher, store, update, extract some properties, and render, and so on. This is the exploded version of this simple pattern of these patterns. These are three representations of the same thing, exploded in various in more detail. Is it clear until now, or I confused you too much? Or you are all sleeping?
No, we are active in the participants. I think it's clear. We get the concept, then let's see later if there is any questions.
Yeah, it is very clear. Actually, it is very interesting. So we are listening carefully.
Yeah.
Okay.
Yeah.
Okay, thank you. Okay, I can go further. Okay, we are almost done with the technologies behind MapStore. We have a big piece apart from that, but we can discuss it later if even you want to go deep down into that, because I'm giving you a lot of information and you may not digest everything if I give you all together. Here, there is a small piece that I didn't explain. This is a call and return service, because all this flow that I explained now is synchronous. So I didn't include it in the loop asynchronous calls, Ajax request I explained here. In Redux, there are some in React. If you are practice of React, you can do, of course, asynchronous calls inside the components, and you can use it internally in the hooks in the latest version, or in the lifecycle methods in the previous. Anyway, I don't. And this is one opportunity. But if you want to update the global state of the application, Redux by itself doesn't include this part, but it allows to include asynchronous or side effects things like this with what they are called middlewares. There is the simplest middleware you can imagine in Redux is called thar, Redux Tank. I don't know what tank means, but basically in this map dispatched propson, anyway, when you dispatch actions, instead of returning objects, as I said, actions are objects. Instead of returning object in actions creators, you can return functions. If you return a function, and you add, of course, this middleware to Redux, there's a function to add the middleware, as you can imagine, there are methods of the store to add the middlewares. You can, if you can return functions, these functions are called and a dispatch method is passed as argument. So you can define action creator this way, returning a function, and this dispatch method is a way to dispatch other actions. What it means, I have, for instance, on click I have to do a AJAX request to the server, and after when I get the result back, for instance, I use Axios or another library to do AJAX request. When I get the result back, I want to dispatch an action to update the state. For instance, yes, for instance, I have here I have an action. So I can define an action that allow me to update the result, and I have also, yes, an action that sorry, I misspelled this one. Result received. So I can define an action that updates my state inside the application. You can imagine there is a reducer that intercepts this action and store the data of the received by the server somewhere, and then I have this action creator that is a tank. It's called a tank, that is an action creator defined this way, returning a function, and I can call the Axios library, and when I get the response, here I have the data here. Sorry, I wrote here. I have data here. Sorry, I modified the wrong yes, the wrong slide. As I said, I have this tank. I can call this function somewhere in my application. For instance, on click on get data, and when I dispatch this action, automatically Redux middleware calls this function and pass the dispatch callback. So I can, for instance, ask my library to get the data, and when I receive the data back, I can call dispatch the action to update the result in the state. This way I can do AJAX request. This is the simpler way you can do AJAX requests in MapStore is included. This middleware is included and is easy. Has some defect because it's the easy things may have cons, and in this case you can, for instance, you have no way to to cancel this request this way, because you cannot call other functions to intercept these actions or these asynchronous things and stop it. For instance, I cannot compose them together. For instance, I cannot do a request or stop, or if I, for instance, click a lot on the button, I have to prevent this function to be called 2 times or 3 times at the same time. And I have no way here to intercept, for instance, a second call and destroy this call or update the events during to this or these or other actions coming in the meanwhile, because we have user interfaces, so interaction is continuous. The user clicks here and there, and sometimes click madly, so you cannot prevent sometimes the clicks that the things that the user does. And you have to handle all these things here. You cannot intercept actions in this way. So, for instance, if I have a button for get data and a button for cancel, I cannot stop this request or intercept or update request due to other actions happening. In general, talking about this more generally, this is a very simple way to do Ajax calls, because you see there are 3 lines of code, but there are some limitation if in case you have a complex asynchronous flow, and it's hard to maintain. You can anyway do something to work around these limitations, because you can, for instance, here I explained only the simpler way, but there is another argument here, that is the store, the state, sorry, a function called get state here. And so here you can get state here and there to for instance to stop it, to check a stopped flag, for instance, and do some checks. But it becomes really hard to maintain if you have many things like this. For instance, here you can avoid to dispatch the action if the things is stopped in the same times. But on the second call, you have to remember to update this stopped value and remove it. For instance, reset to false again. So it's this version is easy, but it's hard to maintain in case of, as I said, the complex asynchronous data flows, more than trivial call and callback. For this reason, in MapStore, we introduced another middleware called redux-observable. There are a couple of them in the Redux world. There is the Redux Saga and redux-observable. We choose the redux-observable in MapStore, and this is part of the next section of this training this day. The purpose of the second part of this training, the next hour more or less, will be to explain this last part of the technology. So, as I said, Tank is the simpler way you can use to do asynchronous calls or asynchronous. Here there was a set timeout. There is a way to delay a request by an interval of 1 second. This is our milliseconds, so 1 second, and you can dispatch this is the same example for the Tank to dispatch an action in delay. For instance, this is an example to do Ajax call. They are two simple things that often happens in applications, but as I said, this this middleware. You can use only you can stop here and use only this middleware if you have to do simple things. But if you want a good interface that interacts to cancellation, interacts with the user actively, I suggest to follow also this part of the training, because it's a very interesting library that, apart from Redux, helps a lot to understand the new paradigm to handle flows, to handle async. Is not the same. Is not the only one, of course, and it may become. It's also a little complicated, and so it may be difficult, but you gain a lot of possibilities if you understand this library. It depends, of course, on the things that you have to do. So basically, this new middleware allow to represents compose and cancel asynchronous actions and create side effects and so on, creating some sort of asynchronous data flows. And of course, it has a dedicated section of the course here. So first, before to start, I'd like to ask you if you have some questions about this part. And we can do a small break before the last part, if you want.
I think, is there anyone who has questions? Gideon.
Yeah, no question from me.
Gideon. No questions. Maybe we can continue. We can stop for the maybe 5 to 10 minutes break.
Yes. Let's
How many minutes?
let's become at we have 5 minutes of break. It's okay. Okay.
Oh, okay. Yeah. Thank you.
Okay.
Okay. See you later. Recording. Okay. Let me restart sharing my screen. You can find many examples of online of what I explained about actions, component reducers, and even the middleware tank. Here, for instance, I can share you in the chat this tool. This is an example of an application that has an action, has some actions that interacts with GitHub, and for instance, I write my GitHub account name, and it loads my profile and so on. Here on the right, you can see the Redux developer tool that allow you to see for each action, these are actions type called the new state that is updated and the action that created it in detail. So, for instance, here when I let me reset. Here there is the initial state. When I write go, it loads. Let me refresh because it's an example and probably 2 times it doesn't work. And here you can see the initial state, for instance. It's only an example, so you don't have to understand every line of code. But, there is a starter request, so there was a loading, some sort of loading tools, and when is such as and there are all other calls to getting the data. For instance, here, get my user data, and then it gets my starred repository. They list them all together here. This uses trunk. This is the reason why I gave it to you. This is a just a second. For instance, here there is a trunk that dispatches the action on when the data has been. You see here the dispatch method, and the get state used to dispatch another action and update the state at such start organizers that will be fetch the data, and when finished, this is another thunk, and that at the end they will return an action with these parts. This maybe contains also other things that are not included in MapStore, but this is an example of what you can see. The interesting part was the developer tools that is present also in MapStore. Just a second, let me start MapStore so I can show you. I can show you the developer tools in MapStore, just to break a little bit between the two sections and start with RxJS. Just a few seconds. I'm starting MapStore in my VS Code. If you install the Redux developer tools in the browser, for applications that contains that have the Redux developer tools here, you will see a new tab here. MapStore allows to activate the developer tools in developer mode if you add the argument debug equal true to the request. And we will see it better tomorrow when we will start developing MapStore actively. Anyway, as you can see here, there is a developer tools that shows every action I perform here. For instance, when I zoom, I update, I have an event widget update property that changes some of the properties. For instance, the zoom of the map here. If I change, for instance, the position, I updated also the center of the map, and all the components react together to this event in order to update their own. So, for instance, let me just to be clear, let me put it in aside the widget. As well as I change the map position, I have an action triggered. The state updates. For instance, the center is updated and the bounding box too. So this bounding box is used by these tools in order to refetch the data and update the statistics. And this is only one example. Every time, as you can see, as I click somewhere here and there, I see many actions. And this tool is very useful to develop because every time you click, for instance, here I have a toggle control with the thrower menu, that is this one enabled. And then if I select, for instance, a layer here, here I have a layer selected event, and here you can see this diff of the state and all the whole state, the action triggered, and so on. So you can see that as well as I click here, I trigger an action like this, and the state changes. These are the changes that has been applied to the state. Some of the tools some of the components of the application are connected to this state, and they are updated accordingly. For instance, as well as I click, I select a node, and these allow this toolbar to show the tools related to this node. If I click, for instance, here and select the node group, this is the default group. The tools are managed because it checks it is a group, and so the tools are different. And that's it. Basically, the properties layer.selected is connected to the toolbar of this table of contents, and every time is updated. If it sees the property selected is enabled, this toolbar checks if it is a layer or it is a group, and shows the buttons accordingly. As well as I click here, another action is triggered. This panel is opened because it's connected to another property, and so on. This is the main concept behind MapStore, and in general behind every application written in React and Redux. Let me open the other, the last part of the course of today. Are you tired?
No.
Okay. Okay. I see you are very strong, so I'm going to make you have headache now. Okay. As I said, the only problem appended with this library is is not a problem by itself, because you can create whatever application you want with this using, for instance, Tank to do asynchronous request, and don't care about this. So if you think that after I explained them, they are too difficult, or they are too, or you don't like them, or you don't want to introduce this complexity to your application, you are free to do, and you can use MapStore without using Epix at all. Without using the new middleware that I'm going to introduce. Anyway, they pay attention because it may be useful to for your use cases. As I said, there is a problem in using Tank with handling complex synchronous data flows and handling cancellation, handling interception, other actions is impossible in this way, and also handling complexity in general. It's difficult because new applications are pretend to be responsive, to be to show active loading tools and so on, and they come with a lot of interactions with the user, and for this reason some of these libraries has been introduced as and in this part of the course I'd like to introduce to you the React, what is the main concept behind this library and how to think in that way, because it's a way of thinking, asynchronous calls. It's a new way of thinking. And at the end, I hope to to make you understand what is a redux-observable, that is the library, the middleware behind the more complex way to do asynchronous things in MapStore that is used for complex for things that have more requirement as simple and Ajax call, not simple delays and so on. First of all, what is reactive programming? Reactive programming is a way to design asynchronous data flows. Is a way to it's a paradigm of asynchronous programming, and it allows to program to create applications focused on asynchronous data streams. What are them? An asynchronous data stream can be everything. Can be all the actions coming from Redux are asynchronous, because you may trigger an action because of a click, or trigger an action because of a response coming from the server. And this is, you can imagine the actions coming from the Redux store as a stream, but also the clicks of the mouse or the events from the user can be imagined as a stream of events on click, anyway, every event, every asynchronous event can be imagined as can be pipelined into a stream of events. Okay, as a concept. Let me unmute other attenders. Okay. Okay. So how can we represent these streams of actions or stream of events, clicks on the mouse, keyboard keys typed on the keyboard by the user or something? Every event flow can be represented as a stream. We can represent it with a line that represents the time. And so every event, because every event happens at a specific time, and we can create balls, marbles in this way, in this time. In this representation is called marble diagram. So this is a marble, and every event can be represented as this marble, as this ball of that it's the effective event. More and this flow of event can be stopped by an error, and this cross on this on the timeline represents an error, and can be closed because sometimes you stop listening for these events, you stop emitting these events, and so this close event means that a stream of events is complete. So this is the main representation when of the events of every kind coming from the user interface, from the Redux store, or whatever level you want. In fact, everything is a stream in this paradigm of programming. A stream. This is the representation of the stream. That is an object in JavaScript that emits events continuously These are the events. It can be at least a stream of click events, or can be a stream coming from the keyboard, and it emits events, errors, or the complete. So you can get this object and observe it, and using the observer design pattern. This is the dual of the observer. It's not the observer pattern if you know the observer, but this is the dual version is observable. So an observable object is an object in JavaScript that has a method subscribe, simple method subscribe that gets 3 callbacks function. One that is invoked every time an event comes. For instance, here you will have 1 call, 2, 3, 4 call to this callback when you subscribe to this stream of events. Then you can see the error. There is a callback dedicated to the errors. So after 4 calls, in this case of this stream, here you will have this method invoked, and then another callback for complete event. So this is the first concept. An observable is an object that you can subscribe, and you can catch new events. Every event comes from here is handled by this function. Every error event is handled by this function, and this complete event is handled by this function. This is similar. This is somehow this is similar to the promise. Apart from the shape that we will see is very similar, there is an analogy between the promise and the observable. Promise can be a simple case of an observable, because promise emits only one value, in this case calling resolve, and then closes. So it does it because it emits only one value. It doesn't need a close event, and as well as the observable, it handles also the error by using catch method. Anyway, so you can imagine a promise as a stream that has only one element and then or error and completes only one of these balls and then completes. So why? This is a generalization, in fact, of the observer is a generalization of the concept of promise. The promise is an object that represents an incomplete operation, and the stream is an object that represents a stream of events, but it's also can be also a promise that it's an incomplete operation with only one that means only one event and then completes. So let's see again this analogy. Promise, it's a special case of an observable as a concept. It as an observable I interchange calling them strings or observable because they are the same things. The observable is an object that you subscribe, and it's also, you can call it also a stream because you can subscribe the stream and listen for it. So I use sometimes stream, sometimes observable, but it means the same thing. You can subscribe to this, so you can subscribe to this stream of events, and listen every time you have a new event coming from this stream. You will have this call, this callback called, and if some errors happens, you can intercept it, and if it completes and closes, the stream is closed, you will have the last call here. This is not needed in promises because the emits only one element, so it's simply that it is implicit that it's complete. So it's nothing new, it's a complication somehow, but you may ask me, what's the reason of this complication? Yeah, because other than the observable pattern, that is a valid pattern by itself for complex asynchronous data flows, RxJS, that is a library that we use in MapStore, provides a toolbox of functions that allow you to combine and merge these event flows and manage them in a very functional way and in very simple way, because simple it's a difficult word because it's not easy, but it's simple. When you understand something, is simple, but it's not easy to understand something. So it's simple as well. It's simple as well as you understand this paradigm becomes simple to solve problems, solve complex problems with this paradigm. So basically, operators in RxJS provides functionalities to create, of course, streams and process streams. So filter, events, delay, create other streams from the other, and all these tools, all these operators, as well as the arrays one, returns other observables, so you can combine them together. And finally, so you will have you can create a complex flow that handles all the events coming from the user, all the complex events you can imagine. Create a pipeline that processes these events and filter and stops and delay and or do asynchronous data request to the server and so on, and wrap it in small observables and combine them together in bigger observable, and at the end have a consumer that will receive simply the final effect. For instance, you can create a stream that from the user inputs of shoot 'em up game creates the final movement that the user have to do. For instance, here I have all the keyboard events, for instance, space for jump and arrows for move. And here I have a complex pipeline that takes into account if the walls of the application or the place where the player is in, the speed is if he's on a train or something like that, and it will whatever it is, all the complexity is handled here, and here you have the final movement of the characters in the game. For instance, if you, for instance, if he's shoot 'em up, you can shoot. The players can shoot clicking on the mouse. You can, for instance, filter the events with the recharge time or something like that, and have the final shoot event here. And you can represent all the events pipelines processing you want with these operators that, as I said, filters, create new streams and so on, and process raw events and get more useful events and more process, and then process them, and then use the final event to do what you need. So as I said, there can be clicks, can be actions, whatever stream of events you can imagine can be processed by these streams and into more useful, more useful systems, more useful function calls and so on, ignoring all the complexity inside. Handling all the complexity inside. For instance, you can collect all the clicks. Here there is an example, and that collects all the clicks that are more than 2. And here you have the click stream, and there are operators that allow you to create a buffer and that allow you to handle the events that happen in a window of 250 milliseconds in this example, and you can bundle them together, then do a map that is very simple, similar to the map used in the array that I explained at the beginning of this in this morning. And you can map this object containing the click events only to again getting the length of this array, for instance, if it is an array, and getting the number of events, and then filtering this, getting only the mouse clicks, the double clicks, and the triple clicks, for instance. Doing this with the usual callbacks, intercepting the on-click and handling the time and checking if the time is expired and so on, is very complex. And in this way, you can do it using this operator. You can do it very quickly with 3 lines of codes, and this is very powerful. So let's start seeing what are the base operators behind this library. First of all, the most simple operators are the creational operators that allow you to create a stream from something. And there is an off operator that allow you to create simply a stream that creates that emits one event and completes. This is off. Just is an old name for this syntax, and but now we use only the images from that documentation, but now we use off. For instance, I can use off 1, and I emit an event with this 1 or a string. As I said, an event can be everything. Can be an event or click or an object or a number or an action. Whatever you want can be an event in this purple. And for instance, I can create an event with number 1, and can imagine an event that emits an event that is the number 1. And here with this operator, I can create a stream that emits the event 1 and completes. A more complex operator gets its from that allow you to create a stream of events from an array. For instance, here you can pass 1, 2, 3, and from this array it creates a stream that emits 3 events, 1 for each element of the array, and then completes. These are the 2 main creational operators that you can see. There was a from promise operator too. This is deprecated now. You can use this slide have to be updated. You can use the fair. In MapStore you will see the fair that gets the function, and it can create a promise here. Here you create, return a new promise here in the defer operator, and this will create this will create a stream coming from a promise. What's the advantage of this? That you can, as I said, promise is a special case of a stream that emits only one event and return and completes. And here you can, this is used often in MapStore because we are using Axios as library, Axios. And then you can use Axios to do this. You can do an Ajax call and then emit the result as an event on the stream. This is very used in MapStore. So in this case, you have the subscribe here, and you can create a promise on the access call, and then you can use the defer that is different from promise, as I said, is deprecated, and you can get the response of the promise, or in this case was resolve for this. This was the same example here, and it simply emits 42 and completes. This stream simply emits 42 and complete after the response is received. This is an asynchronous request. So as well as the server response, you will emit this event and complete the stream. And these are the main, the off, from, and defer are the most common creational operator. And more than, other than these creation operators that are function, you can apply to an existing observable some other operators that allow you to transform, and for this reason they are called transform operators. They can be applied to an existing stream. So for instance, here you have a stream of these events that emits numbers, this number, and you can filter. And in the it's very similar to the arrays we have seen before. You can pass a function to filter the events, and the result, this returns, instead of an array, it returns a new observable that emits a new stream that emits only the events that pass this condition. So as you can, now you can see that you can create a stream of this kind using the array, the from operator, for instance, and then filter. Or you can, for instance, create a stream of, for instance, a set of requests to the server, and then combine them together. And do more complex thing in the next. We will see in the next paragraph. In this next slide, we'll see how to create streams, nested streams. Let me stop sharing to accept again. Okay. Okay. This is a more theoretical lesson. I hope I didn't. Okay. I'm accepting you. You probably. I see you coming and going from the call. Probably you have some issues with the call. Okay. Anyway. There is another common operator in that you can find. There are tree in general. There are switch map or flat map. There are different ways to create complex stream.
Lorenzo, can you share your screen, please?
Yes, sorry, I accepted the new people coming from in the call, and I forgot to reshare. Thank you. Okay. Here, as I said, you have a filter operator, you have many other operators, but more important and more used in MapStore are switch map or flat map that allow you to create a new stream you can apply this operator to a stream, and you can return a new stream here in the function passed here. This function is called every time the action is emitted, and flat map creates a different stream every time a new action comes, and then the final observable contains all the values emitted to the resulting stream. Flat map creates, for instance, here in this example, you have this marble that represents the event, and this is the function as argument of the. It is something like, for instance, the event. This can be, this creates a new observable and returns it. For instance, this is a representation of this. I can do it event, for instance, event. If event is a number, I can do event multiplied by 2 and event multiplied by 3, for instance. This can be a representation of this in code. Every time you receive an event here, the flat map creates a new stream and flatten the events emitted from this stream returned in the resulting stream. So, for instance, I receive an event with 1, 2, and 3, and this will create a new. For each event, it will create a new event, a new stream with 1 multiplied by 2 and 1 multiplied by 3, and it flattens these 2 events in the final stream. So you can see the 1 is red, and here you will have 2 and 3. And then here we said 1. It is red is 1, green is 2, and blue is 3. For each event, for example, for the event 1, it gets the event, it creates a new stream, multiply, and creates two new events that are emitted in the final stream. So here, for 1 multiplied by 2 and 1 multiplied by 3. Then it receives, during the time, another event with 2 as event, and multiplies 2 by 2 and 2 by 3, and emits it in the final stream. And this is a continuous thing, so events may be mixed. It depends of the when they arrived and if they are delayed or not. So in general, you see that they are not in order. It depends. In this case, will be probably in order. You know, if this stream do an AJAX call, for instance, they will not be in order. Anyway, for instance, here in this case, it emits two events for each event emitted here, and 2 for red, 2 for green, and 2 for blue. And this is the flat map definition. The switch map is a more different.
Lorenzo,
Yes.
sorry if I've cut you in the middle, but I've been struggling so much to understand flat map. So can you add another one example of a
Yes.
flat to something that I can easily relate?
Mm-hmm. Yes, sure. For instance, a flat map is useful. Let me think about it. If you let me take this time to admit the other attenders that I have to join. Let me think. For instance, flat map is useful when you, for instance, in the shoot 'em up event example that we need, that I said a couple of minutes ago, this example can be, for instance, if I want to on the user click shoot, for instance, there is a special weapon in my set that when I click, it shoots two bullets. Or for instance, a mitra. I click one, and I want to emit a series of events. I click and I trigger a lot of events at the same time. I have two mitra in hands, so one for each hand. And so if I have a click event and another click event, I have to shoot from both the mitra. Mitra is correct? Mitra in English? Let me. Mitra in English. Mitra is the okay repetition weapon. You click only one because you have you trigger. You have two mitra, one for each hand, and you shoot a lot of events, a lot of bullets from both the mitras.
That's a good example. I get it. I've been in the military, so I can understand. You can shoot once and 30 bullets can go off, right?
Yes.
Yeah, that's a good example. I get it.
Okay. The switch map is as instead an implicit cancellation. Every time the new events comes here, all the events that the previous stream wanted to emit is stopped. So in the switch map, you for this case, if instead of the switch map you have the flat map, in this case, as well as the blue event happens, the green is automatically cancelled. So an example for this is if you have, for instance, in the each mitra has only one. You can have only one finger for. So the stream of one end is if I click 2 or 3 times. Anyway, it will stop. Let me find a better example for this. This is used in MapStore often because if let me go out of the shoot 'em up example, and maybe this is more useful in this time. If I use MapStore, it's easier to understand. As well as I type here. If I change my text inserted here, all the event. If I start typing, the request. This is the geocoder. So if I write some text here, it finds some places that match with this string, okay? And as well as I type, you see that the request start loading. As well as I click N, start loading, and then gives the return, the result. If when loading I type again, all the events coming from here are not useful anymore. The response and doing the request and continuing doing the request is not needed anymore. So when I type, if I change my idea, all the stream can be cancelled. And this is the case of the switch map. That is very important and is very used in MapStore because it's safer and is has many other applications in user interface applications. The same if so as well as I type, for instance, here I am in La Spezia, so La Spezia, and it's so fast, so I cannot I cannot show you. But anyway, you understand. I think you understand the problem. As well as I change my mind and I type new text, the old stream that was getting results from the server is not needed anymore, and we can create a new stream with the new results.
Yeah. So Lorenzo, is it right to say that if you use switch map over flat map, that switch map will perform faster than flat map?
Not faster. The real part is that flat map emits continues on every element that comes from the original stream, continue emitting values. Instead, switch map stops emitting all the values and starts emitting new values.
Yeah. Actually, I wanted to say like you save. I don't know how to put it, but you will make less HTTP requests to the.
Yes. For instance, here you stop asking. Yes, it's important also for cancellation of requests, and it's important for performance because you don't do unnecessary calls and so on. It has a lot of good applications. So every time it's important for search, real-time search, when every time you type search in a search box and you want to have real-time results. For instance, also here I have, for instance, here every time here there is a stream inside this that every time I update, if I update the center very soon, very quickly, the request is cancelled and replaced with a new one. So this is very useful in terms of performance and in terms of automatic cancellation of previous data that you are not interested to anymore. There is also a take until that stops, that allow to listen to another observable and stops the stream. For instance, here I have, I can stop the request from this X button that stops it, and this is very useful because here you intercept an event and you can stop the stream without doing it with a promise, and the tank required that those changes that I needed a flag with cancelled that have to be handled and so on. Instead, this is a simple operator application. And now you didn't see yet the epics, but let's see them because it's late. For instance, search. These are the operators, for instance, for text search. And there is a take until, as well as I trigger the text result purge. The request is stopped, and this is one line of code. And I can do many things with less lines and show only the code that is really needed. And this is useful for programming. There are many other tools I don't want to bore you with, and you can find them on documentation. But the important thing is that you can concatenate many operators at the same time in order to filter, map, switch map, and so on, and handle events as you need. I skip this part because it's not important. Auto-observable and called into you will never find auto-observable in MapStore, so it's not important, and I have to go quickly. So let's see, what is redux-observable? Redux-observable is simply a library to do a middleware using these for Redux, middleware for Redux using these streams. Basically, the core object of redux-observable that has this bad logo, rotating logo that is a little ugly, but it's funny, is an epic. An epic is simply a function that gets the stream of all the actions coming from Redux and returns another stream of actions to emit. So what the main the main flow is an example can be this. I have this this is the stream of all the actions coming from MapStore, for instance, and I emit my application emits an action named ping. I have an epic that creates that reacts to all the action and all the actions coming from the tool and filter only the ones that has the type ping and replies with pong. And so somewhere in the code we have a ping call, for instance, clicking on a button of the mouse, and on each event of type ping, I will reply emitting an action with the type pong, and that can be intercepted from reducers and so on as usual. I can even delay them, but only there is a delay operator that allows to delay one of n milliseconds the stream, so I can intercept the same event, same action, and emit a pong after 1 second. A more concrete example of an epic is this one. For instance, fetch. There is an action called the fetch user, and that is triggered by a button, for instance, on the user interface, and then actions that effectively updates the state with the results with the payload here. An epic will intercept this event this action triggered by the user interface dispatched from the application, and it will do an Ajax call. Here there is an example with an internal library, but anyway you can imagine Axios here, and then we'll reply emitting map, emitting here you see the merge map that is the same of flat map, is another name of flat map, is the same, is an alias. And on every fetch user, I will have a request on the server, and on response, here I return a promise, so it's implicit conversion between observable and promise. And then I can, this emits a new action on the stream, on the final stream. So it finally dispatches the action returned by this, because but basically the epic is a function that gets the initial stream and the action stream and returns another stream of action dispatched. So in this case, this stream is now is not readable because you are new, but as well as you can see, and you can see implicit returns of arrow function and so on. You can see that this stream will emit the result of this function, that is the action. And so every time the fetch user is called, the fetch user, the promise is emitted, and then the fetch user is fulfilled is triggered. Is return is emitted as an event, and so is dispatched to the Redux middleware, to the Redux store, and it updates the results and so on. If I want, what if I want to cancel this? Now is not maybe it's not too much readable, but getting practice with this application, this becomes very when you start to read these operators, it is very simple to understand what the code does. And what if I want to cancel the request? For instance, I have to fetch a button for fetch and loading spinner, and I have a cancel button. I have to simply create another to intercept for an action, the action triggered by the cancel button, and use the tech until operator, and this is cancelled. And I had not to care about flags here and there in the tool. And going ahead with these operators allow you to create this is the old version. I have to update it with a new one. Anyway, this is the first experiment we did with operators with observable, and search this. This is the bar. This is the code for the search bar here. Here in the search bar, I can configure as many services as I want. In this case, I have the two services that I query at the same time. One to get states from this layer, and the other one is the normal nominating, that is an online service that provides roads and so on. So as well as I search for Oregon, for instance, I'll get one result from US states and other results from nominating. So every time, if you see the network, you see that I do two requests at the same time, one to the service nominating and one to the WFS of this layer. And what's the this seems to be complex and instead it's 20 lines of code, included the comments. Now, and because here you filter, you do a request for each service with the text, you merge all the results and update every time the result. Scan is another operator that allow you to update anytime you receive one event, and merge all the results together, and emits the search results action, and it stops automatically on text search reset and so on. And it start with and concat allow you to trigger the loading event and show the spinner here in the, when the loading is started, shows the spinner and stops the spinner. As you can see, is if you had to write this using promise, using Ajax calls and so on, you may need to write hundreds of lines of code. And this is the reason why we introduced it. It's very powerful, especially if you need to do all complex asynchronous data flows and so on. I hope I ran very fast in the last part, but of course this is, as I said, this is a library that requires time to experiment and digest. To get more confident with. So in the meanwhile, you can continue using tanks or using actions as you want that have a lot of documentation around the web, and so you can find a lot of examples about them, and they are simple, and if you don't need it, you don't have to use it. Anyway, take a look that it's very powerful, and it helped a lot, reactive programming in general helped a lot to develop many functionalities like this, like the dashboards, do a lot of usage of reactive programming, not only as epics that are the redux-observable part that allow you to handle redux actions as stream, but also as pure events and properties update. Handling, you can even imagine that the properties of the component are streams. And so this is the case where use it in dashboard, and this is why they are so responsive and so fast. Also, this virtual scrolling that loads events results on demand on when scroll is implemented using the same library. It's very powerful, and that's it. Basically, I finished the theory running very fast with 5 minutes of late. Do you have any questions? I know that I run very fast in this time, so.
Hello, Lorenzo. Sorry.
Yes, tell me.
Yeah, my network is not good. That's why it's sometimes in, sometimes out, especially in the last 15 minutes.
Yes, I
generally,
read it.
The presentation is very good, and the skill that you bring to
you.
us is both from the JavaScript, React, and this MapStore. Is a nice one. Perfect.
Okay, thank you.
Yeah, from my side, I don't have any questions. Let's meet tomorrow, because anytime my network will go out from here, then
okay.
I'll
I see you survived the 3.
Yeah.
Okay.
Yeah.